Okay, in this video, we are further going to work towards a more practical sampling circuit. And what we are going to look at is called a track and hold sampling circuit. So here's how a track and hold sampling circuit would look like. So we have the analog signal here as before. And what we then do is at any point in time, we allow, the sampling of the signal is divided into two parts. In one part, what we basically do is we allow the signal to pass through. So we have this analog signal and this, so in this duration, look at this part of the signal. The output of our sampler is exactly the same as the input. So we are just allowing the input to pass through. And at some point, we just hold the value of analog signal, whatever we get at this instant, we hold it for some more time. Okay, and then what we do is at another time instant, we again go back to tracking our signal, and then we hold the signal for some more time. We go back to tracking our signal, our input signal, and then holding the final value of the input for some time. So that's why this sampler is called a track and a hold sampler. Okay. Now, if you look at this sampler, we have already seen because of the hold in this, the hold is very similar to the zero order hold, and we can see that the output part of the circuit is practical, right? Because you're holding the analog value for some time, whatever circuit goes after this sampler, basically the quantizer will have enough time to do its function. Um, and because we have this track of the signal, and the tracking of the signal is called, we call it the acquisition mode as well. We can see that in the acquisition mode, basically the output is tracking the input, which means that there is uh, basically somehow you connect the input to the output for some time. And that is a very doable thing. And at some point, you remove this connection, but have the last value of your input stored for some time. Okay, think of it this way. Let's say we have a capacitor connected here at the output. So if I connect this input to the capacitor is going to get charged and move along with the input. Okay, then suddenly I take away this input. The capacitor, however, is charged to the final value of the input, and therefore it can hold it for some time. So we have actually managed to make a kind of a practical circuit on the input side as well. So that, in some sense, uh, is the practical version of a sampling device that we can use. So on the input side, we are tracking the input, and that gets rid of the constraint that we had, that we have to sample in an infinitesimal amount of time. And on the output side, we are holding the output for some time, which means that our quantizer can do its work easily.